Okay, let's take a look at the mini whatevers. Just found my last two movies I've made didn't have any sound to them, so this is great. I don't want to click that. Okay. This is a normal distribution on Excel, and this is mini whatevers. Now, what I mean by that, not that my pen will let me write. We're instead of looking at one person, we'll look at 30 people and find their average weight, and what's the probability their average weight is greater than this. Instead of looking at one book, we'll examine 15 books and find a probability that the average number of pages is greater than this. So we're talking about more than one on that. Now, on these examples, my mean, let's say, is 100, and our standard deviation is 5. And I'm going to be dealing with, a pen doesn't write, n is equal to 20. And it doesn't matter what we're talking about. 20 students. And well, that wouldn't be a score, but 20 students and their blood pressure or whatever that might represent. I don't know. IQs. Our first one. Probability that x is going to be less than 95. Now, picture-wise, less than 95 would be this way, which is perfect for the Excel. So we'll go put that in. Okay, so equals norm dist, and what I say, 95, comma, mean, which is 100, or standard deviation, and here we take it and divide it by the square root of n, and we said, I think n was 20, and then 1 for cumulative. So it's exactly the same as what we did with the one whatevers, except for the standard deviation we have to divide by the square root of n. And of course, I'm making numbers up, so this is x is less than 95. Okay. Now, the second one we'll take a look at is where we have probability that x is greater than 100. Well, if we look at the picture, greater than 100 would be shaded this way. And Excel doesn't work with that. It has to be shaded to the left. So we'll subtract it from 1. 1, again, is everything. So if I got the entire bell curve shaded, and if I cross off the area to the left of 100, that'll leave me the area to the right of 100. And now it's in perfect form for Excel. So I do equals 1 minus norm dist and 100, comma, our mean was 100 and our standard deviation was 5, divided by the square root of n, which was 20, and then 1 for cumulative. And that kind of makes sense. That's 0.5 when you think about it. X is greater than 100. Well, let's look between two values. So, I don't know, 70 to 95, for example. Again, same setup as above. Well, between 70 and 95 would look like that, which is no good because Excel wants it shaded to the left. So we're going to do 95 shaded to the left minus then 70 shaded to the left. Because again, if I envision 70 in here, if I got all this area shaded, if I cross off all the area to the left, that'll leave me the area shaded in the middle, which is what I'm wanting. And both of these are going to the left, shaded-wise. So we'll plug both of them into Excel. So this will be equals norm dist 95, comma our mean, which is 100, our standard deviation, which was 5, divide by square root of n, so square root of 20, and then 1 for cumulative, minus norm dist, and what was the next one? 70, comma 100, our mean, comma our standard deviation, divided by square root of n, square root of 20, comma 1 for cumulative, enter. That's interesting. Gives you the same one as that. What are the odds that I would pick something that works out that way? 95 and 70. I guess that makes sense. This is 95, and this is 95 minus 70. But 70 is so far away from the mean, given our standard deviation, that it's practically zero anyway. I'd have to go out to a few more decimal places before I probably actually saw a difference. Like if I started doing this. Or maybe I'd see them exact. Well, that one's exceeded its limits there. Huh. How interesting. They won't always do that, but anyway, this one was between 70 and 95. And those cover all our different cases. So same as before, except for we have to take our standard deviation, divide by square root of n.